So, Uncle Andy's Fireside Chat, talking about some of those things in APL which Dialogue, I think, is very good at telling the world about the big things we do, and we're very poor at telling about the little things we do, the small changes we make. So, I usually get about the last Dialogue slot at one of these conferences because it gives me a chance to point out one or two things that perhaps we should have said. Some little things that I would like to mention in Dialogue 14. Once again, a tiny bit about the trace from the editor, and a little bit more about what Richard talked about earlier with workspace names in 14.1. And I'll finish with a comment that we put in the manual, which I thought was a basis for a slightly longer conversation about perhaps a bit about the way APL works. And after that, I shall exit stage right. So, first of all, if you would like to download the latest RIDE, it is available on the conference attendees website at the moment. We have installation images for Windows, Debian and RPM files for Linux, and an OS X installer as well. It will shortly be available from my.dialogue.com. Funnily enough, Jason and I felt it probably not a good idea to try and put it up at the end of last week, as we had one or two other things to worry about. And the documentation will be ready in the very near future as well. If you have Dialogue APL for OS X, the front end effectively is RIDE. And what we're going to do is make anyone who's got it downloaded for 14.1 already will be able to download a new version so they have the latest version of RIDE. And Nick's Sharpleaf alpha version is also available on the conference attendees website. So, some little things in 14.1 just to be aware of, not to get caught out by. In 14.0 and earlier, you could define a scripted object which had a couple of lines like this. You define foot as a single line defin, and then further down your script you could define it again as another defin, but different. And in 14.0 and earlier, I think APL merely accepted the second one as the correct one. If you tried to do the same with a tradfun or a multi-line defin, you would get an error. And in 14.1 we've changed it so you'd get an error for single line defins as well. Firstly, to make it more consistent from your point of view, and secondly, to be honest, I think it allowed us to fix a number of bugs very simply as well. Those of you who have used the Windows version of Dialogue APL with a language bar, which I think went in 12.1, may have discovered it's possible to move the glyphs around. It is also extremely easy to delete the glyphs, and there is no way back. Having got fed up with having to supply people with the correct registry entries, and of course the registry entry is unique for the version of APL, the width of APL for the edition of APL, I asked John if we could kindly put a reset button on the language bar. So in 14.1 we now have a reset button, or reset context menu item, which allows you to reset the language bar to its default values. If you manage to delete a glyph from the language bar in 14.0 or earlier, please carry on sending us support an email, as we can send you the registry entries to set them back again. This only applies to the old IDE. Nick's RIDE, you are unable to change the language bar at the moment anyway. A regular favourite of the two presentations I have done so far on this, a bit about the trace from the editor. I think this is the best thing that's happened in the trace from editor in 14.1, and that is that you can now move on to, when you're tracing through a defin, or you've got a suspended defin, you can now view what alpha, 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 omega and omega's values are. I don't think we'll ever make them editable, and we haven't added del on the basis that the chances are, if you're in the tracer, you're already looking at del because it's the current function. In 14.0, we added the ability to align comments, but that only ever worked on simple functions. And in 14.1 what we've done is to extend it to allow you to align comments in scripted objects as well. You can either do it on the text that you've selected, you can do it on the current tradfun, or you can do it on the current capsule. Capsules is a word I think you're going to see us using more and more of in the future, as there are more operations we will do at the capsule level. And it's nothing more really than, if you have a nest of defins, it's merely the outermost defin. So say in the case of aligning comments, if you click on a line that is within a dfun within another dfun, the comments will be aligned on the outermost dfun. Another small change we made in 14.1, we added the ability in 14.0 to allow you to, when tracing through a function, skip all blank lines and all comments, with the exception that functions always stop on line 1 when you trace into them, and in a tradfun you will always stop on the last line of the tradfun, whether it's a comment or not, or a blank line comment. In 14.1 we've split that option into two, so that you can now select whether you wish to skip blank lines or not, or whether you wish to skip comment lines or not. That was a result of a certain amount of user feedback. We have also in 14.1 changed or extended prened, or more accurately added a couple of variants to it. You can now call quaded with the variant of read only. And what that allows you to do is to say, or is to prevent you, or the user, changing the object that you're editing. So it's effectively a read-only editor. That only works on objects that could be edited in the first place. We haven't made it so that magically, if you try to edit a numeric matrix and you say read-only 0, this is not now editable. John, I think we'd have to do a fair amount of work before that was the case. The other thing we've done is to allow you to specify that if you double-click on a name when you're running quad ed under program control, you are actually able to open the editor on that name. Up until 14.0, if you call quad ed from within a function with an argument of a list of names, those were the only names that you could look at, could change. And now if you want to, you can specify that if I double-click on a name that wasn't in that list, I can now edit it. It does mean that quad ed now does not necessarily report, the result of quad ed is not necessarily a subset of the arguments that it was passed. The default is to disallow that activity, and it will always remain the default option, and we will not supply a environment variable or an IBeam to override that. So if you want this to work, if you want to be able to call quad ed and allow people to allow you to double-click and edit names that are in there, you will have to explicitly set the variant on it each time. So, workspace file names. Richard mentioned some of this yesterday. Again, I'll reiterate that if you're running on Windows in 14.0 and prior, if you save a workspace called MyWS, the file extension that we've always put on there is uppercase DWS. In 14.1, by default, it will be lowercase DWS. For Windows users, that should make no difference. Dialog APL has always ignored the case of file extensions, so that won't cause you any problems. This is controlled by a variable which Richard mentioned, a variable called WSX, and I just want to explain a bit about it. Why did we do it? Well, the problem is that Windows users expect files to have file extensions, .dws, .txt, .doc. And Unix users generally don't. On Unix, the beginning of every file, particularly binary files, has a digital signature on it, and there is a Unix command called file, which if you run it on against a name of a file, tells you what sort of file it is. We can spend the rest of our existences arguing about which way is correct. There is no one right way. Exactly the same as the system variable who Morton tells me whose name shall no longer be spoken. If you're a Unix person, there is of course the continual schism between the VI and the Emacs users. There is no one right way. Well, this is my presentation, and those are my views on the subject. So, WSX, an environment variable, a configuration parameter that defines what APL will append to a workspace name when you save it or when you try to load it. It's designed to allow you to write somewhat more platform-independent code, particularly I think when you're doing quad CYs that you don't have to worry about, or if I'm on a Windows box it's going to have an extension, if I'm on a Unix box it's not. And when I say Unix I also include OS X in that list. But it can cause some confusion, and you can apparently get slightly odd errors and slightly wondering why is it doing something different. It works differently on different platforms. It's a colon delimited list. with default values on Windows of .dws, colon, and nothing, and on non-Windows platforms, nothing, .dws, and uppercase DWS. So elements can be empty, and the first element is by default used for what is appended to a workspace name when you type save, unless you use explicitly set an extension yourself. On non-Windows platforms, that means that we will look for a .dws or uppercase DWS. If you choose to have an extension of lower d, upper W, lower s, you're on your own. You do need to be slightly careful because wusext and wuspath have an interaction, because obviously with wusext, if you have multiple elements here, which one's it going to look for? Is it going to look for all of those in a particular directory and move on to the next directory, or is it going to effectively for each extension go through the directories? And the answer is that effectively what you do is you say the interpreter will say if it's looking for a file, in this case I search for Andes, and I'll search through all the directories on wuspath to find the file called Andes. And if it doesn't find that, it will then go and search through all the directories on wuspath for the file for a file called andes.dws. And the first time it gets a match, that is the file name it will use. That's fine, because when you actually load a workspace, it tells you, the interpreter tells you exactly where it's found it. If you call drop, so you want to delete a workspace name, we actually search through all the directories with all of the possible wus extensions, and if there are multiple hits, we don't do anything other than display the entire list in the session, because we're not entirely sure which one you want to delete, and we'd rather that you had to do a bit more work to specify it precisely, rather than us getting it wrong. So, for the non-Unix users amongst us, what that says is give me a recursive listing of the current directory. And in this directory I have a subdirectory called 1 with a file called Andes, and a subdirectory called 2 with a file called andes.dws. They are copies of the same file. And so on a Unix box, in this case AX, I set my wuspath to be 1:2, so that is the subdirectory called 1 in my current directory, and the subdirectory called 2 in my current directory, and I start APL, and I type load Andes. Then, because my default wusext starts with an empty value, the file I find is the file called Andes. So I load the workspace Andes. If I'm on Windows, for start, wuspath is separated by semicolons, and I type load Andes. Here, I search for, first of all, a file with .dws on the end of it, and of course since it's Windows it's case insensitive, so the file I find, well that one doesn't match it anymore because I'm now looking for andes.dws. It will find this one, and therefore I load andes.dws. So just be careful if you start writing cross-platform, multi-platform code, that we've tried to make it a bit easier by effectively behind the scenes coping with file extensions for workspaces. But just be aware you might have to just remember this example means that you may not pick up the file you necessarily expect. My strong recommendation would be that if you are going for a multi-platform environment, is that you define your own workspace extension and keep it the same across all platforms. The default is DWS. If you want to call it .app, .xyz, whatever, that's fine, that will work just as well. So if you look at prenwusit, that will always include any file extension, and on Windows we will always put a dot at the end of it if there is no file extension, just to indicate that there isn't one. And as Richard mentioned, quite important, none of this changes the way quadwusit works. And one of the reasons for that is quadwusit, I believe, was used quite extensively in shared variables, and although not many people may use them anymore, if we were to change the way that works, anyone who's got an application that uses shared variables would have to change their code. Okay. This section is a little bit about how Dialog APL, the workspace, works, and comes from this comment that appears in the documentation for 127 IBEAM. It is the responsibility of the programmer to ensure there are no used pockets in the workspace that reference the data. I'm going to mention pockets. I'll mention Quad WA, a couple of I-beams, some more system functions. I'm not going to talk about what the vast majority of the contents of a pocket is, or what sort of pockets there are, what's going on in the workspace. That is the way Dialog APL works. It changes between versions, and is something that effectively we feel we have the right to change. And I won't really talk about how memory is managed in the workspace, although that is quite well documented these days. If you start looking at Quad WA 2000 I-beam, there are links onto other pages in the documentation. So, let's start with a bit of data. I wrote my presentation at the beginning of August, and it was going to say the cat sat on the mat. But I found across this particular stream of characters on the 6th of August. I might mention what it is later on. There may be one or two in the audience who recognise that. Possibly not. And just as a slight aside, I've got to say, isn't key a wonderful operator? I create a variable with that text in it, and what I want to do is to find the unique elements of that data and the count of them. And I've merely sorted on the first first column of the matrix so I get them in an order that I want. This expression, comma dot tally, can also be written in this form of alpha, comma, tally omega. It's really useful, this. It's a wonderful way of showing that APL is how powerful it is, in my opinion. And of course, if you're an England cricket supporter, it's wonderful because it is the history of the Australian first innings, which was unique in history. It's the first time a team has been bowled out at international level in the morning. UK Crime Stoppers is an organisation that you can contact if you suspect a crime has been committed, and apparently they actually tweeted, "We can't take any calls about the criminal Australian batting." So, what is a workspace? A workspace is a lot of pockets and an awful lot of pointers. And here, for example, we have a symbol which points to a class pocket, and a class has some symbols. In this case, it's pointing to a function, and the function has some data, multiple data, and all sorts of other pockets which I'm not going to mention. Let's start with a simple thing. We want to erase an object. So here I have a symbol which points to a data pocket with the word hello in it. And what I've done here is I've erased the object, and you can see there is no longer a pointer to this particular value here. Because there is no value there, there is no pointer to there, it is now free space. But what we haven't done is we haven't deleted that string. It's just sitting there in the workspace at the moment. And that's why we introduced 127 I-beam. And what that says is, if I call 127 I-beam Zilda, then go through all the free space in the workspace and replace whatever values there in the first place with, it's actually a string of, I suspect, character 170s. Hex AA, yeah. So the whole point about 127 I-beam is, if you had that symbol contained your secret password or whatever, and you delete the variable, the text is not automatically cleared out of your workspace at that point. Okay, 127 I-beam will force that to happen because we overwrite all free pockets. And the other thing that happens is that we have compaction. Here we have multiple free spaces throughout the workspace, and when we compact a workspace, all that does is shuffle all of the used pockets up to the beginning of the workspace, and you end up with one huge free pocket at the end. If you force a compaction, you will override any pockets that have been freed up, except for potentially ones at the end, I believe. So, back to my data pocket. Here's my data. It's a character vector. It's a character array. It's a vector. It has length. It has rank 1, and it has a length of 113. And I define a variable, so innings is assigned that 113 characters. I still have my original pocket, which I've defined here, and then I say I want to create a pocket type symbol. It has a name of innings, and its value is this pocket here. So a very simple variable has two pockets. If I have a nested variable, so innings is the end close of my character string, I have my data, a vector, character vector of rank 1 and length 113. I have my symbol, which is a symbol pocket with the name innings2, but its value points to a pointer pocket. It's a scalar, so it has rank 0 and it has no length. And here there's a pointer to the data. So a simply nested variable takes up 3 pockets. If I have my variable innings down here, and I go and create a new variable, I really want to talk about this. This was wonderful, this. So I create a matrix of 5 rows and 2 columns. Then I define a symbol pocket with a name worth repeating, which points to a pointer pocket of rank 2, length 5 rows, and 2 columns. And here I have 10 data pointers to data, but they all point to the same single pocket. Okay? So although you may think you've got effectively 10 lots of that character vector, in this case there's only one of them. Dialog APL does not do automatic sharing, so if I define a variable A, I'm going to end up with 2 pockets, a symbol pocket which points to a data pocket with hello. And then I define B, which is hello again. That's another pocket type symbol with another pocket with a value of hello. But if I say A gets hello and B gets A, then you end up with 2 symbol pockets and 1 data pocket. So again, when you look at A gets hello, B gets A, start asking your question, how big is A? How big is B? And you have to start thinking about, what do you mean by that? What do you want to find out from that information? And a more extreme example, if I say C is 2E6 reshape enclosure hello, I end up with 1 symbol pocket, 1 data pocket which has 2 E6 pointers in it, and because I have said it's the reshape of the enclosure of A, the data pockets, all of the pointers in the data pocket point up to this data pocket up here. So you can create very large arrays that don't take up much space in the workspace. The downside of that is that you have a large array which reuses the same pocket, shares it. It is extremely easy to stop sharing pockets. And in this case, merely by trying to append a character A to each of the elements of C, you get a wasteful if your workspace, if you're using default size workspaces. The reason is each element has to be generated, and each element is separate from all the others. Why does APL not realise that I could actually get away with just changing the single data pocket? And the reason is, it's the overhead of working out whether I can do that or not, and that's quite an unusual thing to do, I think I would say. So it's, with all of these things, it's a question of performance against the amount of space we use, and in this case it's easier to say, okay, we'll just blow up the variable. Here, however, I change 1 element of the 2E6 elements, and that's fine because I've still got 1 less than 2E6 elements pointing to hello, and now I have 1 new data pocket with hello A in it. So, how can you find out what's going on in a workspace? Well, you've got quad size. It reports what an object would take up if no pocket sharing was occurring. In many cases, you do have pockets being shared, and using quad size to work out how much space an object takes up or how much space will be freed up if you deleted an object it's not terribly useful. Let's say it this way, it doesn't give you particularly useful values. It's best used on numeric and character data. You can take the quad size, I believe, of a namespace. Who knows what that means? Quad WA is more useful. It reports how much space there left is in the workspace. However, it's a heavy operation. It forces a compaction. Compaction means everything in your workspace is moved up to the beginning of the workspace. 64 megabyte workspace, not too bad. 16 gigabyte workspace, significant pause potentially on your computer. 96 gigabyte workspaces, I won't say go and have lunch, but you're going to have a long pause at that point. Not only does it force a compaction, before it shuffles all the data up to the beginning of the workspace, it tries to squeeze data. A character is a character in most cases. Unicode, it might be a 2-byte character, however. But a number, how do you hold number 2, for example, number 1? In number 2, is it a single byte integer, a 2-byte integer, a 4-byte integer, a floating point number? One approach would be to say every single time we create an array, we could say, well, let's squeeze it down at that point. And if it squeezes down, you save some space. But the effort in squeezing something is quite heavy, so we are a little bit more parsimonious about when we do that. We don't squeeze things as often as perhaps we could do for performance reasons. So, and to use quad DR, that shows you, I believe the documentation says, it tells you the type of the data array. What is in there, but perhaps not so obvious, but it attempts to squeeze the data first of all. So it tells you the type of the data after you have called quad DR and not before it. And again, when you do a quad WA, it tries and squeezes everything in the workspace. So again, slows quad WA down. So do not put too many quad WAs in your application, because it will slow it down. Given these limitations, we've added some I-beams to Dialog APL. I do recommend looking at 2000 I-beam. I won't say it's the answer to every question you're going to have about your workspace, but it does a pretty good job. 2000 I-beam 0 gives you a quick workspace available. It tells you how much space there is in the workspace, how much space there is free in the workspace. It doesn't do a squeeze, it doesn't do a compaction, and there is a little bit of, I wouldn't say it was accurate to the nearest byte, but it's pretty close. 2000 I-beam 1 tells you the amount of workspace used. And again, there is a little bit of approximation, no squeezing. And the other one that's really useful is 2000 I-beam 2, and it tells you the number of compactions since the workspace was loaded. In an ideal world, in your application, you should never have a compaction, because effectively that means that you're wasting time whilst all the information in the workspace is shuffled up to the beginning. If you have a lot of them, delete some stuff out of your workspace. That may be tricky if it's all your functions, or make your maximum workspace larger. When you install Dialog APL for the first time, the maximum workspace you can create is 64 megabytes. We've tested up to about a 95 gigabyte workspace. So there is some room in there for choosing sensible values. Again, if you define it, we used to say you had to specify it in the number of kilobytes. So max was equal to 64,000. At some point we added the ability to say 64M, 64G, and for those of you who've got very deep pockets, I think you can have 64E and 64P. Please, if you get to the petabyte size of workspaces, would you have a word with us, because I think we'd all like to retire at that point. So, 2000 I-beam, it's worth looking at. It tells you a bit about your workspace, and when you're trying to work out why your application's running slowly, it's worth seeing what's going on, particularly with this value. Do remember, if your code calls quad WA, the number of compactions will increase by 1 every single time you call quad WA. So if you've got a tight loop that does quad WA, look and you see I've got 1,000 compactions, don't start thinking, oh dear, my workspace isn't big enough. First of all, check that you're not artificially incrementing that value. I think I'll skip that one for now, since we've got 15 minutes left. 181 I-beam is an attempt to improve on quad DR. It's quad DR without the squeeze. And effectively what that says is, tell me the data type of the argument to 181 I-beam, but don't do a squeeze. You cannot 100% rely on that not having been squeezed, because if you had a workspace compaction because APL needs to get a bit more space to return the result of that, there will be a compaction at that point. But in 99.99 times out of 100%, you will end up with the type of array it was. So, a very quick example. This was going to be a live example, but I decided that if I'm going to have to bend down to type on my keyboard, it's going to go horribly wrong, so it's now yet another PowerPoint slide. So, I make a note of the first 3 values that's reported by 2000 I-beam. I have a 64 megabyte workspace. This is on Windows, 64-bit, and what that tells me is that I'm already using about 1 megabyte of workspace at the 6-space prompt, and that's because, of course, you've got a session file, and the session file takes up workspace. If I do a quad WA, when you start APL, it loads a session file. There's a bit of work going on from Salt. It frees up makes a few pockets. We've freed up a few. So when you do a quad WA, the amount of workspace the amount of workspace available increases slightly because I've just removed a few free pockets. Now I create a variable 2e6 reshape enclose hello, and I question 2000 IBM again, and you can see the amount of workspace used has gone from about 1 megabyte up to 16 megabytes ish, and the number of compactions has actually gone up too. And one of those is because I suspect just creating the pocket containing that stuff has forced a compaction, and one more for the quad WA. And if we look at the difference between the amount of space available, the amount of space used, and the number of compactions that has happened as a result of that quad WA and that assignment, and that expression as well, you can see those two numbers are one's the negative value of the other, which is what you'd expect, but we've used up just under 16 megabytes of workspace to hold this variable. Well, quad size is obviously going to say 16 megabytes, isn't it? Well, it actually says 96 megabytes, because what it said is how much space would this variable take up if there were no shared pockets. So C actually physically takes up about 16 megabytes. If each of those was a separate pocket, you'd need to have 96 megabytes of workspace to hold that variable. Okay. So quad size is not as useful as it might be. You have to decide quite what it is. What is it you actually want to know? Because it's certainly not the amount of space it's the amount of space that's being taken up by that variable, but that is not necessarily what you're expecting. So, back to the original comment. What's going on? So I have a function. Again, this is a very, very simplified model of what's going on in the workspace. The expression other metadata hides a multitude of sins and a multitude of other things going on. So I'm going to define a symbol with the name of Andes. It is a namespace, and there's some slightly odd stuff going on with the name, and the contents. And the contents include a function pocket with a name of foo, and here is the source code for foo. So create a namespace and quad fx foo or whatever. If I start calling foo, I will create a symbol pocket with the name of secret with a value of my secret. It's a character vector of length 8. When I get to line 3, I will generate an error. I'm doing a division by 0. Quad DMX at that point has to make a note of, or point us to, the namespace, the function, and the symbols. And the reason we do that is the vast majority of times that you actually generate an error, you don't care what quad DM or quad DMX are. You don't want to look at them. You merely want to trap them and move on. So quad DM and quad DMX are not, the character representations are only created when you ask for them, when you actually refer to DM, DMX. So, having run that, and I've now run my function back at the 6-place prompt, I delete the namespace Andes, and effectively all that does is to free that pocket up. I've marked it as deleted, but we'll worry about that. We've already gone through that. But DMX still has pointers to this information. There is therefore at least one pointer pointing to each of those pockets, and because there's at least one pointer, we can't get rid of it. So that information, although you've actually deleted the namespace Andes, is still present in the workspace. If you save the workspace, that will be saved as part of the workspace. So, I'm now at a 6-place prompt, and at the 6-place prompt simply type divide 0. That's an error. So, this is rather back to front this, but I think this makes the models slightly easier here. I've now generated an error. Quad DM now points to the information that is a result of this error message, and therefore can free up these 3 pointers. They're not needed anymore. Because they're freed up, this and this are freed up, and because that is freed up, that is as well. Okay? And at that point, you have deleted everything to do with the namespace Andes, and you have deleted the pocket that you probably wanted to be freed up in the first place, which is the text My Secret. Okay. So, be aware, when you use 127 iBeam and it says we will delete any pocket, we will overwrite the contents of any free pocket, you need to think about whether it's possible that pocket hasn't been freed up yet. And you may have, again, if you say my secret gets my password, my secret 2 gets my secret, then you've now got 2 pointers to the same pocket. So if you delete one of those names, the other one's still there. So have you intentionally or have you unintentionally shared the data pocket? Okay. Equally well, when you save a workspace, it's probably worth asking whether it's worth doing a reset. If you do a paren reset or you force another error, it means that quad DM will be a known value. And that will free up any pockets that you may have not freed up as you meant to. And the other thing is, it's no bad thing once in a while saving the workspace and then copying it into a clear workspace if you're still using workspace technology. And this is one of the reasons where using scripted objects has a lot to be said for it, because you don't have this cruft, if you like, left lying around. You're starting from a clean point each time. Okay? And when you're developing code, ask yourselves, what are you hoping to learn by using quad size or quad WA or quad DR? And make use of the iBeams instead. And that is that. Okay.